So I love Aubrey de Grey. He's the great modern pioneering popularizer of the science of longevity and the very idea that death can and should be treated like a disease. And as you've seen, he lives the life to the fullest, and that was a contribution he made to a pilot episode of a current affairs program that runs on Vision TV called The Zoomer. So that's the electronic Aubrey, and normally I'd be calling the real-life Aubrey on stage. Oh, here he is. Aubrey, come on out here.
Doing my best.
Yeah.
It's a little.
All right. So he's got the controls.
Here we go. Whoa, I'm out of control. Somebody stop that.
All right.
All right.
Now, Aubrey, you were supposed to be on stage with me right now, and you aren't, which means you've been a bad boy. Please explain yourself.
Yes, I suppose I've been a bad boy. Ultimately, I think the way in which I have been bad is simply by working too hard. Because what happened was that I was supposed to be on a red-eye from San Francisco last night, arriving in Toronto early this morning, and everything went fine, all the way up until I got to my gate at 11 p.m. last night in San Francisco, and I sat down and I fell asleep. And the gate agents didn't notice me, and everybody got on the flight, and they paged me repeatedly, and I didn't wake up, and the flight went away. And I woke up 20 minutes after the flight had taxied. United Airlines did their absolute utmost for me. I have no complaints. They did everything they possibly could to get me to Toronto in time to give this talk, but they couldn't find a way to do it. However, on the bright side, first of all, I slept in my own bed, and I have a beer. And also, I have the glorious thrill of driving a robot around the stage at IdeaCity, which is something that I have certainly never done before. So, all in all, I think it's worked out pretty well.
So you can imagine, Aubrey, it was a bit of a shock for me when I woke this morning to find your email waiting for me. But here you are, and it's the miracle of modern life, isn't it, that he's available to us by Skype and on this beam. I hope you can stick with us regardless of the video quality. So, Aubrey, here's your audience. Away you go.
Thanks very much. First of all, I'd like to say that Moses' introduction was a little bit out of date in that my wife will actually be 71 a week from today, and we're still having sex twice a day, so everything's looking good. I apologize that, so far as I know, the robot does not have a beard, which would have been even better, but there you go. And I also apologize for the fact that I'm going to have to rush this talk because I've been told that I really do need to get through it in 15 minutes. And since we're doing it this way, it's going to have to be rather old school. I'm going to have to say, next slide, please, every so often. But we'll see how it goes. So, next slide, please. Great. So, this is a graph showing how much progress we have made since about 1950 and through to a projection out to 2050 in increasing longevity. This is for the USA, but the statistics would, of course, be very similar for Canada or other developed nations. And what we're seeing here is simply the proportion of the population that is over the age of 65. It's gone up enormously. Now, of course, that is a source of celebration. It has mainly been the result of our ability to more or less eliminate infant mortality in the developed world, and indeed mortality in childbirth and so on. So that's wonderful. But on the next slide, we see one illustration of the downside of that success, namely that people are living long enough in larger numbers to suffer the diseases and disabilities of old age. What we see here is, and in this case it's from 1960 through to 2010, again in the USA. What we see in the red line is the growth in the size of the US economy, and the blue line is the growth in US medical expenditure over the same period. Drawn like that, it doesn't look too scary, but it looks extremely scary if you divide one by the other, and you get the green line, which shows that expenditure has gone up from only 5% of the economy of the GDP up to 18% in 50 years. So we all know this is breaking pension plans, it's a disaster. And it's, of course, an enormous disaster, not just economically, but in a humanitarian sense. So next slide, please. So we have to ask this question. Why have we been so unsuccessful against the diseases of old age when we have done so much to eliminate the diseases of early life? And this is a question that people don't ask themselves enough. Next slide, please. Most people would give this answer. They would say, don't worry, you're not supposed to be able to read this slide. The point here is an awful lot of things go wrong with us during life, and they interact, they exacerbate each other. It's just a really nasty, complicated problem. Most people would say that's the main reason why we have been so unsuccessful in keeping people healthy in old age. And that certainly is one reason. It's not the only reason. Next slide, please. In order to introduce the main reason, I'm going to describe to you what aging really is. Most people think aging is some kind of mystery, some kind of bizarre, poorly understood phenomenon. It's not. It's actually very well understood. Aging is simply the accumulation of damage. In other words, aging of the human body, or of any other living organism, is just the same as aging of an inanimate machine with moving parts, like a car or an aeroplane. Any machine with moving parts does damage to itself throughout its existence as a side effect of its normal operation. And the machine is set up to tolerate a certain amount of that damage, but eventually there's too much damage and the function of the machine starts to decline. It's exactly the same for you and me. Next slide, please. Now, what does that mean? What that means is we can describe aging in 3 words. Metabolism, that's the word that biologists use to describe the whole of what keeps us alive, all the network of processes that keep us ticking over from one day to the next. Metabolism has side effects. It creates damage. Damage accumulates throughout life, even starting before we're born, and eventually there's too much damage and we start to have the pathologies of old age. Next slide, please. So the thing is, most people make an inaccurate, incorrect distinction in their minds with regard to what aging is. If you look at this table, what you see is 4 types of ways to be sick. Column 1 is infection. And we all understand what infections are. They come from outside of the body, and we have medicine to eliminate them. Then there's column 2, that's congenital diseases. Diseases that we're born with as a result of mistakes in our genetic makeup. Then there's column 3, which is the chronic, progressive diseases of old age, like Alzheimer's. Those are the things that are the source of the overwhelming majority of the medical budget of any developed country and even of the developing world now, and we're obviously very keen to try to fix them. And then there's column 4. Now, column 4, aging itself, it consists of these very non-specific, nebulous phenomena that we don't think of as diseases. Things like sarcopenia, which is the loss of muscle as one gets older. These things are important, they're bad for us, but we don't think of them as diseases, and that's an enormous problem, that big black line that I'm showing you. We think of aging as somehow not even in principle amenable to medical intervention. Next slide, please. This is how we should be thinking about the classification. All 4 columns are the same, but the black line's in a different place. There is no difference of any kind of biological significance between column 3 and column 4. They are both aspects of aging. They are both side effects of having been alive a long time. That's all they are. And if we understood that, then we would be much better off. The consequence of not understanding it is that we are far too optimistic about the ability to cure the things in column 3. We think of them very much like the things in column 1, as things that could be eliminated from the body. It's nonsense. But it also makes us far too pessimistic about the things in column 4. It makes us think that there's no way we can do anything about aging because it's just not a disease. That's nonsense. Next slide, please. So this is another way of putting it. We think of the diseases of old age, those pathologies on the bottom right, as things that can be directly attacked and expunged from the body, like infection. And it's no surprise, now you've seen what I said in the past couple of minutes, that geriatric medicine doesn't work, that we get a very, very modest postponement of the ill health of old age by that means. It's just never going to work. So, next slide. I am not the first person to point this out. More than 100 years ago, a few people started to think this way. They said, well, this is not going to work. We've got to try and intervene at an earlier stage in the chain of events. And that's where the field of gerontology comes from. The idea that maybe we can look at nature, we can see that some species age more slowly than others, and even within a species, some individuals age a bit more slowly than others. Maybe we can understand that variation thoroughly enough that we can translate that understanding into a therapeutic paradigm and actually slow down the rate at which the body creates damage in the first place, which of course would postpone the pathology. But there are two problems with that approach as well. The first problem is that it only gives a substantial benefit if you do it starting at an early age. If you take someone who's already in middle age and you start doing this, then you're not going to get much benefit because they've already accumulated a lot of damage at the normal rate. The second problem is even more severe. Next slide, please. It's this. Metabolism is rather complicated. This is a simplified diagram of a small subset of what we know about how the body works, about how metabolism works. And as you can see, those of you who are programmers will understand that this is basically a morass of uncommented spaghetti code. There is absolutely no way that we would ever be able to tweak this morass in such a way as to stop it doing the thing we don't want it to do, the creation of damage, without stopping it from doing things we need it to do, keeping us alive. It's just not going to happen. And of course, that's an understatement. The real problem is that this is a simplified diagram of a small subset of what we know about how the body works. And any biologist will tell you that that is completely dwarfed by the astronomical amount that we don't know about how the body works. Even ignoring all the stuff that we don't even know that we don't know. You know, it's just never going to happen. Next slide, please. So, what's the solution? Well, the reason I'm here today, insofar as I'm here, is that there is a third way. I call it the engineering approach or the maintenance approach. Rather than trying to slow down the process by which metabolism creates damage, or the process by which damage translates into pathology, instead we uncouple those two processes from each other. We go in and repair the damage periodically, not necessarily completely, but quite a lot of it, so that even though it's being created still, it does not reach the pathogenic level. And that's what my work is all about. Next slide, please. Why do I think this is such an effective approach? Why am I so optimistic? Ultimately, I'm optimistic largely because we already know that it works. If we go back to what I said about aging of a living organism being basically the same thing as aging of any inanimate machine with moving parts, then we can go back and look at cars. We can see that this is exactly the way that we extend a car's lifespan. This car here is more than 100 years old. And the thing is, it was not designed to last that long. It was only designed to last maybe 10 or 15 years at the outside. The reason it has lasted many times longer is simply that it has received comprehensive, periodic, preventative maintenance throughout its existence. And that is all that I'm saying about aging of the human body. We can achieve the same effect, essentially indefinite postponement of functional decline, whether mental or physical, by preventative maintenance. Next slide, please. So I'm not going to get technical today, partly because I've only got 15 minutes and partly because you're not biologists, but this is basically what it's all about. In the year 2000, 15 years ago, I was able to not only make the insight that I've just described to you, but also to take the next step and subdivide the problem. These 7 categories that you can see on the left-hand side of this table are types of damage. They are things that cumulatively happen in the body. Cell loss, simply cells dying and not being automatically replaced by the division of other cells. Molecular waste products accumulating, whether inside the cell or outside the cell, things like that. And the purpose of this classification, the utility of it, comes from the right-hand side of the table. The fact that for each of these types of damage, there is a generic therapy, an approach to actually fixing the damage, not just stopping it from happening in the first place, but fixing it even after it's happened, that can be used for any example within the category, with only minor changes of detail of how it's actually implemented. So that's what we work on. And it's looking very promising right now that this paradigm, this classification, is really correct because it's standing the test of time. As you see at the bottom, it's looking very unlikely that there's going to be category number 8 turning up anytime soon. Next slide, please. I'm going to just very briefly go through one example of what we do. SENS Research Foundation is a biomedical research charity based in California, down in Mountain View, and we do our actual research. We have a very small budget, only $5 million a year, and we certainly wish we had another zero on the end of that, because then we could go a lot faster. But with the small amount we do have, we get a lot done. And I'm just going to tell you about one of the projects that we have supported over the past few years. What you're seeing on this slide is a microscopic image of the first stage of atherosclerosis. You all know atherosclerosis is the #1 killer in the Western world. It causes heart attacks and strokes. It starts by white blood cells invading the artery wall to clean up detritus that has been stuck in the artery wall. And those white blood cells know what they're doing. They do it very well. But there are certain contaminants in that detritus which poison the white blood cell. And eventually they can't do their job anymore. And they turn into what you're seeing here, a foam cell, which is full of fatty lipids. We know, people have known for a long time, what's going on here at the molecular level. They have identified various molecules that are poisonous to white blood cells. In particular, one molecule called 7-ketocholesterol seems to be the most important. And they know that this is what drives it. If white blood cells could process 7-ketocholesterol well, then they would not turn into foam cells, and we would not get atherosclerosis. So that is what we want to deliver. On the next slide, I'm showing you what we have done so far. We have identified bacteria that can break down 7-ketocholesterol, and we have identified the genes with which they do it, the enzymes with which they do it. Now that was actually relatively easy, those 2 steps. The third step was harder, but we managed it a couple of years ago. We have been able to put that enzyme into human cells and modify it in such a way that it still works. And this slide shows you that for various different concentrations of this nasty molecule, 7-ketocholesterol, the right-hand bar is taller than the other bars, which is to say that cells which have our engineered gene are protected. They survive better in the concentration of the toxin than other cells that don't have the enzyme or they've got the wrong enzyme or whatever. Next slide, please. Now, you may be thinking, well, this sounds all pretty interesting, but hey, you know, there's this guy, he's just saying all these things. Maybe he's not really, not really right. Maybe the scientific consensus is that aging is actually not a disease and it can't be amenable to medical intervention. So I want to give you a little bit of appeal to authority for a moment and emphasize that we are not just some kind of voice in the wilderness here. What you're seeing here is our research advisory board, 25 people who are absolute world-leading luminaries in various of the fields that we are working in fact, all of the fields that we're working in. These people have signed up to align themselves with our approach, and they are, you know, very strongly supportive of what we're doing. Next slide, please. Furthermore, we've got, of course, the more conventional measure of mainstream credibility, publication in the peer-reviewed literature. This is just a selection of the papers that we've published in the past few years. Next slide, please. Next slide, please. Thank you. All right. So you may be thinking, well, okay, so if this science is legitimate and promising, and if really, you know, it's also generally accepted, what's missing? Why is the budget of SENS Research Foundation only $5 million a year? I've put a few things up there to show you what's going on at the moment. The past couple of years have been very good years for the anti-aging mission in terms of credibility and publicity. Google created an offshoot company called Calico, which brought in very high-powered biotechnology business people to try to cure aging. 2 extremely larger-than-life visionaries, Peter Diamandis and Craig Venter, got together to form a company called Human Longevity Incorporated, which is doing the same kind of thing. And even the mainstream academics who are not on our research advisory board, people who have historically not really been involved in this, have started to reinvent what we have been saying for the past decade. A paper came out a couple of years ago called The Hallmarks of Aging, which is being cited far more often than anything I ever published. And it's basically a restatement. Yeah, it's very nice. So what's missing? Next slide, please. Well, there you have it. This is the thing. It's all real it's just psychology. People don't like to change their mind. Next slide, please. We could put it this way. People have decided that aging is inevitable, and in order to put it out of their mind and get on with their miserably short lives and not be preoccupied by this terrible thing, they've also found ways to pretend that aging is actually a good thing, that it's desirable. And these two mistakes have conspired to entrench each other. I think that's probably the best way to put it. It is almost impossible to have a serious conversation with most people about whether aging really is inevitable, because they don't care, because they've decided that it's a good thing that aging exists, because otherwise there would be, I don't know, overpopulation or whatever, and therefore, even if we could fix it, we wouldn't want to, or we shouldn't. And unfortunately, the same people have the converse problem as well. It's pretty much impossible to have a serious conversation about whether aging actually is a good thing, because they've already decided that the question is academic, because aging is a fact of life. Fixing aging is like creating perpetual motion. So I spend an enormous amount of my time embarrassing people into not doing what you see on this slide, embarrassing people into addressing these two questions separately from each other. Next slide, please. This is the biggest thing that I always have to get across to people. Half of the stories that are written about me and so on are entitled with some title that has the word immortality or living forever in the title. I do not work on immortality. I do not work on longevity. I work on health. Just like any other biomedical research organization, SENS Research Foundation is all about keeping people healthy. And yes, there is a side effect of that, which is that people on average live longer. In our case, if we are as successful as we think we are going to be, there will be a really big side effect. People are likely to live a lot longer. But it's still a side effect. Ultimately, if you are going around saying that what we are doing is not important or is a bad idea or whatever, then what you are saying is that it's a good thing that old people get sick. And I do not meet anybody who is willing to stand up and admit that they think it's a good thing that old people get sick. Next slide, please. So ultimately, when I get these kinds of responses, you know, oh dear, there's too many people, or won't dictators live forever, and so on, you know, I feel very sad. On the one hand, you know, there are easy answers to these questions, like, you know, dictators, I mean, come on. Last I looked, dictator was fairly high on the league table of risky jobs. You know, most dictators don't actually die of aging in the first place. Next slide. So, you know, I really don't want to talk about these. But here's the thing. Next slide, please. Here's the reason I don't want to talk about them. For any particular reservation that you may have about the desirability of eliminating aging, bringing aging under comprehensive medical control, there are two moral challenges. And these moral challenges are applicable to every single challenge you may have. The first one is, how big are these problems? Let's just suppose, hypothetically, that we don't increase the carrying capacity of the planet by using renewable energy rather than fossil fuels, and therefore we end up in a situation where we do need to have fewer children than we would like in order to keep enough space for all these irritating old people who are still healthy and therefore not dying. Supposing that happens, you know, seriously, should we be killing the old people? Should we be letting the old people endure this debilitation and disease and dependence and general misery and death just so that we can have more kids? Does that really make sense? And the second thing, which is perhaps an even more decisive moral argument, is the question of who should have the choice. Ultimately, if we say, oh dear, you know, overpopulation, or, you know, how we pay the pensions or whatever, let's not go there, then what we would be doing is condemning an entire cohort of the future of humanity to an unnecessarily early and unnecessarily painful death on the basis of our anticipation of what is good for them. Whereas, if we develop these therapies as fast as we can, we will be giving humanity of the future the choice, the option to use the therapies or not to. It's clear to me that that is our moral obligation. We do not know whether there will be enough solar energy or nuclear fusion or whatever to be able to alleviate any potential overpopulation issue. We do not know what other aspects of society will be different in the future. So we cannot morally justifiably make that decision on the basis of the future. Next slide, please. So ultimately, these are the ways that we should be thinking about the societal considerations. We should be remembering that we're talking about a world in which nobody gets the diseases of old age, in which the elderly are fully able-bodied members of society, contributing wealth, making everybody more prosperous, despite the fact that the therapies will cost something, and so on. You know, this is where we ought to be. Next slide, please. I'm not quite sure what everyone's laughing at. I have a feeling Moses is making noises at me to say stop. Okay, that's good, because this is my penultimate slide. This is a book I wrote several years ago. It's still very handy. It's quite technical, but it doesn't require biological training to read it, so I recommend it. Next slide, please. And finally, I just want to mention that I hope that you will do better than me 2 months from now. In August, we have a conference that we're running in San Francisco, just by the airport. It's going to be a fantastic showcase of not just of academic work, but also industry participation in the burgeoning, emerging rejuvenation biotechnology industry. Next slide, please. And that is it. Thank you very much.
Aubrey. Thank you for rocking and rolling with us, Aubrey. I appreciate your talk. I know you couldn't see the timer, and so we all understand why you ran a little long, but better that you arrived here than that you didn't materialize at all. One last word, Aubrey. I once spoke at Aubrey's conference, and we agreed to swap appearances. So I don't consider this a full physical live appearance, and you still owe me a trip to Toronto one of these years.
It's a deal. And also, I very much hope that you will appear, whether electronically or in person, at one of our conferences, perhaps next year. I'll be in touch.
Fair enough. Thanks a lot, Aubrey.
Thank you.